These are the only three possible problems from section 4.5. Either the exponential growth, or the exponential decay, or the logistic growth function. So let's look at 88. Is anyone with me? Please say yes. Anybody?
Yes.
Okay, thank you.
Yes.
So we have f of t equals 500,000 divided by 1 plus 2,499 e to negative 0.92 t. Okay, so they are giving us the function. We have to read carefully the measurement units for each. Models the number of people. Okay, in a city who have become ill with the virus T weeks after its initial outbreak. We had a very similar problem last time. So T is in weeks. Okay, I made my note. How many people became ill with the virus when the epidemic began? What am I asked to find? How many people became ill with the virus when the epidemic began?
You will have to find the zero, right?
F of 0, indeed. Thank you so much. Original, initial, beginning. All of them mean f of 0. Excellent. Not difficult. How come? Because when t is 0, the power is 0, but e to 0 is 1. 1 times 2,499 is 2,499. Plus 1. Plus 1 is 2,500. So then I have 500,000 divided by 2,500. No issue, no problem. 50 divided by 25 is 2, so that's 200 people. I simplified 2 zeros with 2 zeros. I divided 50 by 25 and I got 2, and there are 2 zeros left. So initially, when the outbreak began, 200 people were sick. Good. Part B. How many people were ill by the end of the 6th week? What am I asked to do now?
D will equal 6, so you'll have to plug in 6.
Exactly. So we have to find f of 6. Good. I'm not going to put this in the graphing calculator as is. I mean, plug it in every now and then. No. Please, learn this from me. It is the best way to see the function. Make sure you're not making an error when you enter it. So 500,000 at the top. It's only one number, which is okay, one term, but the denominator has to be in parentheses. So it's 1 plus 2,499 times e. Careful how you come up with the e. I recommend parentheses because I don't know what calculator you have. Minus 0.92. There is no t. We have to use x, but that's okay. And don't forget to come down. No, sorry. Oh no. What is going on? Don't forget to put parentheses after that. Okay, that's it. And now I can plug in anything I want. And if you have any doubts, when you plug in 0, and you see you get to 100. Now I have to plug in 6. And I got huge. 45,410 people. Some will say because it's 7, rounded up. I can't round up people, but I'm fine with either one. So 45,411 people. For some reason, I put the dollar sign. Nobody knows why. Good. Now, the last question is, and I like this question, what is the limiting size of the population? What does it mean that gets ill, that becomes ill? Meaning, okay, we know what happens after 6 weeks. What about after 10 weeks? What about after 100 weeks? What about after 2,000 weeks? If you have any problems with that, you already have the function. You have the function, just plug in whatever you want after 6. Uh-oh. Okay, good. So after 6, let's say 100 weeks. 500,000, of course. Let's say after 200 weeks. 500,000, of course. Let's say after 1,000 weeks. Of course. So then I know that assuming there's, as I mentioned last time, there are no visitors, nothing comes out of the town, nobody comes in to visit. This is the maximum number of people that can get sick. Again, if we have 10 people in a family, how many can they get sick? 10 maximum. Hopefully none, but the maximum is in this case, which means in part C, as t increases, we say, without bound, f of t gets closer and closer to 500,000 people. We have 10 people, only 10 people can get sick. That's the maximum. This is all about 4.5, which I think is the most difficult, but as you see, it's not that difficult if you're paying attention and you redo the problems. Okay, let's go backwards to equations. So that was section 4.5. Now we're going back to section 4.4. So here it is. So we have exponential equations and we have log equations. You choose from 64 to 73 and from 74 to 79. Any exponential, any log equations. So let's practice, please.
We do 70.
Yes, very good. Let's start with 70. I see it, very good. That's my page 7. Good. In 70 we have e to 12 minus 5x minus 7 equals 123. Perfect. It's all the same theme. What are we going to do first? What is the first step? So e to 12 minus 5x minus 7 equals 123.
You'll add 7.
Absolutely, clean it up. It's not cleaned up and it's not ready for applying log because I cannot apply log to a difference. So of course I will move 7 to the other side. In other words, it's negative here, it will be positive here. 123 plus 7 is 130. Now I'm ready for the step-by-step procedure. Of course I will apply natural log to both sides. Of course 12 minus 5x goes in front, but natural log e is 1. Of course, the right-hand side is natural log of 130. If you feel more comfortable to put in parentheses, please do so. Same thing. And now this is just a simple number. It looks fantastic, but it's just a poor number. So I have to move 12 and divide by negative 5. So negative 5x equals negative 12 plus natural log of 130. And now I divide both sides by negative 5. I prefer dividing term by term. So x equals 12 divided by 5 minus 1/5 natural log of 130. Yes, you should approximate it and then plug it back in to make sure that your answer is correct. So let's approximate it first, and then we go back and plug it in. I don't want to miss points. I can make a mistake at any point in time, so I want to check my work. So I'm checking now 12 divided by 5 minus, in front I have 1 over 5, which is 0.2. Natural log 130. And close. And enter. So approximately 1.4265. Is this correct? I don't know. But I'm going to put e to the power, and the power is 12 minus 5 times the previous answer. Close the parenthesis. Come down from there. Subtract 7. When I hit enter, what should I get? If I don't, I know that that 1.4265 is not correct. What should I get when I hit enter? If the answer is correct.
1.4265.
Careful, careful, let's do this one more time. 12 minus 5 times the previous answer minus 7 should give us
123.
exactly. Let's check. If it doesn't, I'll say no way. This 1 point blah 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 makes no sense. And here it is. So 12 minus 5 multiplied by the answer we got, close the parenthesis, minus 7, we got 123 as expected. Now I know I don't need anybody's help or advice or anything to support me. I know this is the correct answer. I checked. Good. Okay. Any exponential, any log. And then we go back to other topics. Anything else?
79.
Say it again.
The 79.
Yes, of course, we'll look at 79, but you don't need any more exponentials? Are we okay with exponentials? I mean, we can go back. It doesn't matter. Sure. So let's continue with 79. In 79, we have log base 4 of 2x plus 1 equals log base 4 of x minus 3 plus log base 4 of x plus 5. Good. Remember the domain of a log. This has to be positive, not 0. This has to be positive, not 0. This has to be positive, not 0. One of the questions, if you use it here or not, one of the questions will be to find the domain. So it's better to practice the domain than just plug and chuck, right? So 2x plus 1 has to be strictly greater than 0. X minus 3 has to be strictly, not 0, strictly greater. And x plus 5, strictly greater. It will only take a few seconds to work on this. So this means greater than negative 1/2. This means greater than 3. And this means greater than negative 5. So if you put them on the real line or number line, very easy to find the common territory. So I have greater than negative 1/2. Then I have greater than 3. And then I have greater than negative 5. Which territory has all 3 different colors? Because all 3 logs have to be, they have to exist at the same time.
The 3.
Exactly. So the domain of this whole thing, domain, is 3 to infinity. What am I saying with this? If I do not find a number that is strictly greater than 3, then this equation has no solutions. Good. So we establish where the solution will be found, if there is one. No guarantee, but if it's not here, it's not the solution. Okay, so now I will copy the left-hand side as is, leave it alone. But I have to look at the right-hand side and I have to condense. To condense. How do I condense log of this plus log of this? There are three properties. Which property do we use here?
Would it be division?
Careful. When there is subtraction, yes. When there is addition,
Multiplication.
indeed, exactly. Very good. So this will be log base 4 of x minus 3 and x plus 5. Exactly. So now, I stop and I ask myself the following question. I have my props here. I have two logs with the same base that are equal. What can you tell me about these two quantities for this to work? What can you say about these two quantities? Two logs in the same base are equal. What can we say about this quantity and this quantity?
We have to set them equal to each other?
They must be equal to each other. I've seen it, please don't do that. I'm not saying you're going to. Some students just cross out as if they are dividing both sides by log base 4. No, you cannot do that. So please don't do that. So here's the idea. Two logs in the same base applied to these quantities are equal to each other. The quantities must equal each other. There is no other way. Because log base 4 of 5 does not equal log base 4 of 10. So this quantity and this quantity have to be the same. Otherwise, the equal symbol will not work. Because if this is 5 and this product is 10, they're not equal. If this is 5, this has to be 5. If this is 10, this has to be 10. Good, very good, thank you. So then 2x plus 1 has to equal x minus 3 times x plus 5. So now, from a complicated log equation, I changed it into a simple log equation, and now I change it into a polynomial equation, which is quadratic. So the left-hand side is 2x plus 1. The right-hand side I have to distribute. X squared plus 5x minus 3x minus 15. Quadratic. I have to set it equal to 0. I have x squared. I have plus 2x. But 5x minus 3x is 2x. That will simplify with the 2x from the other side. And then I have minus 16. I have two options. You can move negative 16 and take the square root, or you can factor and get two options. And you can say, not too fast. What am I saying? This is what I'm saying. We did all this work. What do I conclude? What's the conclusion?
Equals 4.
Only x equals 4. No. And you can always go back and check if you want to. Plug 4 in here, plug 4 in here. You see, the negative 4 will not work. Negative 4 minus 3 is negative 7. Law cannot be applied to negative 7. If you ever want to double check that, very simple, very easy. Go to the calculator and put in natural log of negative 10, and the calculator will scream at me. Well, they'll say you lost your mind. Not possible. Law cannot even be applied to 0. If I put 0, it will scream at me again. You lost your mind. Okay, perfect. Moving on. Anything else from 64 to 79? And this is section 4.4. And we go back to 4.3 after that.
Can we do 67?
Of course. So let's look at 67. 67. 67, yes. 9 raised to x plus 2 equals 27 raised to negative x. Good. This is a nice and beautiful situation. Why? Because both bases, left and right, can be written with the same base. How do I know? Well, I know that 9 is 3 squared. And I know that 27 is 3 to the third. So this is a very nice situation.